Recording. All right. How was your weekend? Long weekend it was. Didn't seem long enough, of course, but it does. Did get you any more sleep? Anybody get any more sleep? More sleep, I hope. Let me get over here. Hi, Cheyenne. Did you get any better sleep? Did you get in some Z's? No? Oh, okay. Didn't need the extra sleep, or you had just a lot of things going on? Yikes. Hey, Janaya. Hey, Jay. Okay, it was a good day. Okay, cool. So good to see you all. We got about 16 people. So here is the week agenda for this week. So we're going to talk about the phases of matter. Understand that states of matter can help you understand how materials behave in different situations. For example, understanding the properties of solids can help you understand why bridges don't collapse under the weight of cars. Understanding the property of liquids can help you understand how water moves through plants. Understanding the process of gases can help you understand how air pressure affects weather patterns. Film red made me want to break my phone because it ended stupidly. Oh, got to watch DBS. I like One Piece. Is that the one with Luffy? Um, oh yeah, yeah. I guess I didn't realize that it was a comic book, graphic novel, and then there was lots of um, television broadcasts of that, so it's been around. But I really like it. I like it a lot. It's pretty cool. But yeah, I didn't like. Were you talking about? Um, I forget who read, but yeah, It's a cool. I like it a lot. So 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 anyway, so this is your assignments today. Phases of matter. We're going to do the intro today. Um, there's your video. There's your notes. This is the assignment. And remember, we'll go over this assignment probably on tomorrow. We'll probably go over this assignment tomorrow, but we'll be going over that. So if you look in your modules, um, see week three, come on, week three. Okay. So here are your phases of matter notes. There's a bonus. We're going to do that bonus today. Um, then we'll go over the homework assignment. That's assignment on phases. So there's a lot of things we're going to be doing today. Okay. So the first thing that we want to do is I want you guys to do. Hey, good morning, Tim. I'm going to clear the chat a minute, just so you guys don't get distracted by. Um, so here is okay. I'm going to send this to you guys. This is a state of matter pretest. Okay, I'm going to send you a link. Copy it. All right, so this is, and you, if you would be so kind as to take this. Oh, yeah, I just have to log back in. If you just click up there, it'll by your name in the upper right hand corner, Roman. It will link you in there. So that does that for me too. Okay, so this is a pretest. Just want to know what you know, so I can go over material with you. So if you could do that real quickly, I'll give you 10 minutes till 9:20. It's a bonus exercise. I added to your participation points. So go ahead and do that. And tell me when you get done. I'll know when I see the responses click in. So I'm going to start taking attendance on the, where are you? Okay, this is, yep, September 5th. All right, so go ahead and do that. Again, it's 10 or 11 questions, 12 questions. And, you know, again, it accounts regardless of your grade. It just tells me what you know at the moment. You don't have to search them up. You don't have to go to try to find the answer on Google, on the Google search bar. Just go ahead and tell me what you know. Tell me what you know. And then again, it helps me drive my instruction, really helps me out. So like I said, you got 9 more minutes to get that done. I'm going to turn the pause on the, and hopefully we're taking the time to help you out with being keeping up on track here, using the hour wisely, right? By not just sitting in the background and doing nothing. Hopefully, if you're sitting in the background, you're doing something. You're doing the assignments that we're working with together. You're taking notes, things like that. Okay, you shouldn't have to be watching the video unless you're not able to get to the class. All right, 2 more minutes and counting. Should have a timer on this. Is it not? Let me double check. Yep, the Nearpod, I have given this link. Okay, 9:19. All right, see if anybody's gotten in there. At 6. Oh, you know what? That doesn't look like the right one, does it? Let me double check here. Well, let me double check here. All right, let's try this again. Yep, I don't know how I did that one. Yeah, that's it. You're right. I'm glad let's try this one here. Okay. All right, time's up, ladies and gentlemen. Thank you much. Okay. So this one is just, I'm going to turn my self off here a second. Make sure that I have the video here. There's 10 questions. Okay, so I want to do me off, not that off. Okay, sorry about that. All right, so entire presentation. Sure. So this is like 3-minute video just to catch us up on what is water and states of matter of water. Okay. All right. So I've got one person in so far. Sorry about that, the earlier one, guys. Let me close this out here. And thank you for those 8 or 9 people that did that assignment. All right, I got one person so far. Okay. I'll wait for you guys to get in. Try it again, guys, ladies and gentlemen. Two people. All right, let's take a look at this.
So I wanted to talk to people about the different states of matter, solid, liquid, and gas, using water as an example. But I thought first I better be sure that we're all on the same page about what water is made of. What's water made of?
Water?
Yeah. What makes water?
Water.
Okay, what elements does it take to make water?
H2O.
So what does that mean?
That is water.
What elements? Water and cold. Water plus cold.
But what does the H and the O mean?
Something in oxygen.
Something in oxygen.
Hydrogen.
There you go.
Hydrogen.
All right. So what two atoms make up water, the water molecule? Choose two answers. Two answers. So what two things, okay, right, should have hydrogen, H2O, hydrogen and oxygen, right? Hydrogen, thank you for those 9 people to get in there. Water, just to refresh your memory. Okay, you never know when this guy from Veritasium comes to the park near you and asks you questions. Water and oxygen.
Hydrogen and oxygen. What's the two
Hydrogen,
mean?
oxygen.
Hydrogen, oxygen.
And the two, H2O. Why do we say two?
I don't know.
It's 2 particles of hydrogen and 1 of oxygen.
There you go. So that.
Okay, so what's the 2 stand for in 2O? Is it the number of oxygen atoms in the water molecule, or is it the number of hydrogen atoms in the water molecule? Yeah, you guys got it. Number of hydrogen atoms, right? Right, almost got everybody there. 30%, so that means out of 10, 3 of you haven't answered. Maybe you have a glitch. If you have a glitch, put it in the private chat so that I know that I'm giving you points today. So if you put down hydrogen, you're not able to get into Nearpod, you can always put it in the private chat. Remember, that's what we always do.
That makes what we call a water compound. two atoms of hydrogen and 1 atom of oxygen makes a water molecule. I know, the word was like on the tip of your tongue. I guess we got.
Okay, so 2 atoms of hydrogen and 1 atom of oxygen come together to form a water what? Element, atom, molecule. There you go. I sure you guys got that really quick. 4 of you got it real quick. 6 more to go. Again, like I said, you could put that in the private chat. We got 26 people here. 50-50, 5 and 5. Sometimes the Nearpod takes a while for it to click in. There we go. 2 people's left. All right, 2 people
Got there in the
walked
end.
away.
So what's the difference between solid and liquid water?
So obviously the temperature of it. It's a lot colder.
Ice is frozen.
What does it mean to be frozen then?
Cold.
Liquid water is no good for skating on. Ice is great. Yeah.
Nothing other than temperature.
So everyone recognizes that temperature is important in determining whether the water is ice or liquid. Well, what's actually happening between the water molecules? What's the difference between water and ice?
It's frozen.
What does it mean for something to be frozen?
It's solid.
What does it mean for something to be solid?
That it's like a brick.
It's like a brick. And what makes it like a brick? What's happening in there?
I don't know.
But what makes it a solid versus a liquid?
Well, in this case, lots of pipes going underneath. But
That makes it very cold.
makes it very, very cold. Yeah.
But what's actually happening to the little bits of water?
They're attaching to each other. They're attaching. I mean, this is all we're guesswork here. I imagine they're attaching to each other. They're forming a more solid interpiece.
You cool liquid water down, and then at some point, what happens to it?
It slows down, freezes, and stops moving.
The molecules become frozen.
How do they become frozen?
They join together. They accumulate. They coagulate.
Coagulate is not the technical term for it, but everyone was on the right track. In ice, the water molecules are basically fixed in place. They form a crystal lattice where their only motion is vibrating. So what
All right, in solid, frozen water, the molecules do which of the following? Check all the three apply. They freely flow past each other, are limited to vibration as a form of movement, are fixed in place, form a crystal lattice. So, yep, B is one of those, and C is one of those, and D is one of those. So B, C, D, it doesn't freely flow past. So crystal lattice. All right, we got 3 people left, 70%, 3 people left. All right, so we've got 10%, just 1 person left. All right, so all those things, when you get it cold, vibration starts to vibrate rather than move around. So it's in a fixed place and forms a crystal lattice.
what happens if we heat up the ice? Like what happens when like a solid melts?
They all bounce out and
What are we talking about?
melt.
What are they doing?
Well, like in science, you draw little circles.
What are those little circles?
Oxygen.
Are they just oxygen?
Hydrogen, oxygen. And the two.
And the two.
The temperature is higher.
So the particles, they're less stable.
Yeah.
Less stable?
Not stable.
More free to move around.
That sounds right.
All right, as the temperature increases, the weak bonds between solid water molecules break, and water molecules do what? Remain in fixed position, move around freely. Yeah, you guys got it, move around freely. So the more energy they have, they break the weak bonds between the solid pieces, and then they move around more freely, and then it becomes liquid water. Okay, and we got 3 more people, 2 more people. Thanks, guys, for getting in there.
They become separate and they are allowed to move around. And in gas, maybe they're further apart. Is that what we're okay?
This is
yeah,
fantastic.
That
This
makes
guy's
sense.
nailed it.
All right, that makes sense.
That's
now.
all.
All right, water vapor gas molecules are blank than liquid water, further apart or closer apart. Hey, Jay, can we focus on what we're doing right now? Okay, and keep the chat just science related. We'll talk a little bit at the end of the hour. Appreciate it. Yeah, so they're further apart. Gas molecules are further apart. It's all right. I appreciate the chat. I appreciate people interested in chatting.
That's awesome.
All right.
So in liquid water, the water molecules not only vibrate, they can also rotate and slide.
Okay, so which of the liquid water molecules can do the following? Okay, so vibrate, rotate, slide past each other, or all the above? Yeah, you guys got it, all the above. We're losing some people. We got a bunch of laggy computers. We only got 1 person responding there. They vibrate, rotate, and slide past each other, so they're all the above. Okay, thanks, Jada. It just doesn't show. It might be my computer's laggy. All right. Not a problem.
Past each other. And this is what allows the substance to flow. At even higher temperatures, the water molecules become free of that liquid and turn into water vapor. In that state, they are very, very far apart and moving very quickly.
So in the gas state, water vapor molecules are blank to apply, very far apart, very close together, moving very quickly, moving slowly. Right? So A is correct and C is correct. Very far apart and moving very quickly. Good job, guys.
Very quickly. So the major differences between solid, liquid, and gas are the motion of the particles and the distance between them. Of course.
Okay, the major differences between states of matter and water are the mass of the molecule, the motion of the particle, and the distance between the particles. So check 2. So yep, it's the motion of the particles, higher temperature, they move more quickly, and the distance between them, right? B, and C. Thanks, guys. All right. So we're going to take a look at this PhET simulation, okay? So this talks about pressure and also talks about you can add molecules to it. So we're going to click on water here. You can see water molecules. You can add heat to it. You can see the temperature goes up when I do that. So I have it in Celsius. There's 32 degrees Celsius. And it's in liquid form at this particular case because they're moving around each other. As I add heat and get it to move around, you can see that you get some gas and some liquid at this point. And eventually, when we get it hot enough, we can turn it all into just gas. And you can see the motion of those. We can cool this off. Where we start slowing the temperature down, bringing the cooling it off. And then you'll notice that it starts to slow way down, and then they start to form that crystal lattice again. Now, the interesting thing about water is that the shape of it, the crystal lattice, it doesn't show it here, but it's larger than its liquid form. Most things, when they become solid, their volume comes smaller. Here it becomes, it actually gets larger. And that's why when you put something in the freezer, your water bottle can shatter. Now, temperatures here can be in Kelvin, and 0K. Look at this. No movement at all. That's called absolute zero. 0K is absolute zero. It's not something we get really close to absolute zero in the laboratory, but we never get there. So there is some slight vibration in there. So Z is our absolute value here. So I'm going to ask you, absolute zero, no motion, right? Everything and that's everything. So if I go argon, I can get it down to 0K. See, it's get no motion at all. And you can see there's still some slight vibrations in there. Let me get it to 0. Okay, no motion at all. Absolute value. Absolute 0, not absolute value. That is a math problem here. Okay, so let's take a look at the next one here. All right, so students. Okay, so in this particular one, you can click on this link here. All right, Nearpod. Okay, this is hopefully what I wanted to do here. Nope. Resume. Okay. Not sure you're able to do this or not, but I'll go back one here. Okay, what they're asking you for. Okay, I can't do 2 screens at once. Okay. All right. This is getting confusing for me. So at absolute zero, the temperature is achieved when everything becomes a solid. Scientists have achieved, well, it says about 1K. What is that in Celsius? Okay, so let's take a look at that. over here. Can I get that on this without disrupting it? I guess I have to go back. So if we can cool this down to 1K, cold, cold, cold. All right, so 1K is minus 272 degrees Celsius. So minus 273 is absolute zero. So let's write that down here. All right, so I'm going to write that down. 1K is equal to minus 272 degrees Celsius. So that's where scientists get 0K is equal to absolute zero. Okay, which is equal to minus 273 Celsius, and there's no motion. Okay. Now, we're running out of time here as far as to take a picture of the triple point, but we will do that in a little bit here. I want to get to the bonus assignment. So the triple point is where the temperature at which gas, liquid, and solid are all in this at the same point. There's a gas, some liquid, and some solid. Right, so just write that 1K is where the scientists get to, is minus 272, and 0K is absolute value. I'll let you guys see this again. Oh, most of you guys got it. ZJ, thanks for getting that in there. Jada, thanks. Let me get you back to take a look at this. All right. Okay, I'm going to switch over to give you like another minute, 9:40. 1K is where scientists get. This is what we'd say science gets us here. Science. We're able to achieve that in the science lab. Science lab, we can get that. Not us, but it's really hard to do. But 0K, absolute value, we're at no movement at all. Okay. All right. Thanks for getting in there, ladies and gentlemen. So let's take a look at the notes we have today. Now, my friend, Mr. B, Mr. Barnes, he likes anime stuff, and so he is responsible for this week's slides. We share the work, so he does his slides, I do my slides. His are much more interesting than mine. So he wants to say to you guys, are you getting your total hours in? Offline tracker videos are a suggestion for notes. So if you want to do some offline tracker this week, you can watch some videos on freezing and melting. I'll submit some for you so you can use that. So Mr. Barnes, B squared, Brinton Barnes. So the classification of matter is what we'll be talking about today, more in depth. The ICANN statement, I can review what matter is versus examples with matter is not. I can complete the in-class pre-assessment. We've done that. All right, so we're going to, again, some of this stuff we've done, we're going to review matter, what it is and isn't in the pre-assessment. So you guys did that for me. ask questions, and review past week's notes. So these are the notes that you're receiving. These are the notes that are in the home page and as well as in the module. All right, so so as a review, matter is anything that takes up mass and takes up space and is a place where the object can exist and move or have volume. Example, a brick has mass and takes up space, a desk has mass and takes up space, a pencil has mass and takes up space, and air has mass and takes up space. So in the chat, if you tell me one thing that you think is not mass or volume. I'm a drawer and that's tough. I don't understand that. ZJ, are you talking to me or are you talking to other people? Oh, okay. Thanks, Revi. I didn't understand that. I'm a drawer. Okay. Yeah, I got it. He's talking about so anything that's not matter. Yeah, thanks, Revi. You're right. It is. Light is not matter because it doesn't doesn't have volume, and it doesn't have any mass to it. It's one of the few things that can travel very fast. If you were like light, you could travel very fast, but we don't. All right, so phases of matter. Now, phases, what they're talking about here, so like you probably heard of phases of the moon. So phases of the moon, right? We've got the crescent moon, we got a half moon, right? And we got a full moon. So those are changes in the moon, right? So we use that same word, changes in matter. So this is what this means, changes. So a lot of people had trouble last year when I was explaining this. So I'd say, what are the phases? And you've got solid, liquid, gas. Now, your phases of the moon, you have the crescent, half moon, full moon. So you think of the word to be the same. All right. So we did the pre-assessment already. All right, and let's see here. I can compare and contrast, so my I can statements, I can compare and contrast characteristics of liquid, solid, liquid, gas. I can describe how temperature and pressure determines the state of matter, and I can start to review the states of matter triangle. So we're going to try to do that assignment, the bonus assignment here in a minute or so. Okay, so phases of matter, remember we did this last week, rigid, fixed shape, fixed volume, liquid, not rigid, no fixed shape, fixed volume, and then gas, not rigid, no fixed volume, no fixed shape. So the main difference, as we said in the video here, the main difference between phases is distance between the molecules and the kinetic energy or the speed. So kinetic energy are the motion of the atoms. So, and when solids have the low kinetic energy, they're sticking together, and the attractions of the atoms. So when they're going very slow, they're really attracted to each other and they stick together. They just vibrate. When they're going faster, the distance gets further, okay? Less attraction between the molecules or the atoms, right? Getting to flow past them. And when we get to a gas, the distance becomes the greatest and the attraction becomes the weakest. The attraction between the atoms is the weakest. So atoms, the smallest unit of matter, purple circle, speed and atom attraction is affected by temperature and heating and pressure. Pressure means to compress or add pressure. To cool is to compress. To heat is to reduce pressure. So cool and heat. So we're going to use these arrows here to cool and talk about cooling and heating. And the phase of matter. So we got solid, liquid, and gas again. So as the kinetic energy goes up, you'll notice that it goes from solid, liquid to gas. The particle motion gets bigger, and the force of the attraction gets less. Okay, so as we increase the heat, this is called a direct relationship. Okay, direct relationship means if I increase the temperature, increase the temp, okay, the kinetic energy increases. Ke goes up, particle motion goes up, Pe particle motion, PM, that should be PM here. Particle motion goes up. Particle motion goes up. So that's a direct relation. As one goes up, the other goes up, or if one goes down, the other one goes down. But the attraction, as the temp goes up, the attraction goes down. Attraction goes down. So that's what they call an inverse relationship. Inverse. Inverse just means as one goes up, one goes down. Okay, so this is what we're going to try to do the last few minutes of class here. Try to work on this. So all matter phases, so this is spelled Canadian way, vaporization. So going from a liquid to a gas is called vaporization. Continue, don't have to put, and we are adding temperature, heat to this. So we have a red arrow. Condensation, where we're taking a gas and making it into a liquid, we're cooling it down, right? Ones that you're not so used to is sublimation. If you've ever gotten dry ice at Halloween time, actually you need to be 18 to get it at some stores because it's it's very cold, minus 39 degrees Fahrenheit, and it could burn you. Sublimation is changing directly from a solid to a gas. And if you've ever seen CO2, that's how they make the fog machines. Deposition sounds like something, if you look it up, it talks about depositing dirt. Deposition is going from gas to solid. That happens a lot in the wintertime where the gas vapors will turn right into ice on grass blades. So this is deposition. We're cooling it down. And then, of course, liquid to freezing is colder, but then melting go the other direction. Okay, so I'm going to have you guys help me out with this. Okay, I'm going to give you this assignment here. So I'm going to keep this. Let me go make this a little smaller here. Smaller, smaller, smaller. So if we go to, I will give you this link here, ladies and gentlemen. Not that, right here. So this is the bonus assignment. Come on. So if you go to your particular assignment here, you go to modules. This is where all the bonus assignments go. And states of matter bonus. All right, so this is kind of a writing assignment there. I'm going to give you that, clear this out. All right, if you link that, I will, let me see, where's mine? Mine's the teacher version right here. And where are my slides? Here we go. Just want to get you on doing this. You can use the slides with this. We're gonna do it together here. So I did make this work. So how many people got in there? Let me know if you're in there. All right. Make this a little bit smaller here. Actually, here we go. Okay. So I show you, I made it so that you could type right in there. So I'm going to make this larger just for a moment. And then I'm going to type in VAPOR, vaporization. I'm going to make this a little bigger to see. So I'm going to make it like that. Vaporization. Now I can move it a little bit so that I can, there we go, making that look there. And now what I'm going to do is I'm make it a little shorter here. And then I'm going to get an arrow. So I go to the arrow line here. So I go to the arrow. And I'm going to make a little arrow that points in this direction. Okay, now I'm going to make it red. So I've got to change it to red. And I'm going to make it bigger. Okay. So I'm going to do that all over again so that you guys can see how I do it. Okay. So I'm going to go back. Okay, so I typed in vaporization and I made it bigger. Okay. Right. I basically just highlighted this and I went to increase the font so I can make it, I'll actually make it 21 this time. Next, I went to the line drawing part. Here I used the arrow key. It was set on line. I put it onto the arrow, drew my arrow in that direction because red arrow temperature of the objects is hotter. So from liquid to gas, it's hotter. So we're adding energy to it. So I'm going to change the color here to red, and then I'm going to make it bigger. So I have a red arrow. Anybody need to see that again? Make it so that it you can show me again here. Anybody need help on that? Okay, so that's vaporization. Let me turn this over here. So the next one we're going to do is condensation. Okay, condensation. And we're going to put a blue arrow because when we go from gas to liquid, it's going to get colder. Condensation. Not a problem. I like that, Revy. Okay. So Revy says she just changed the color of the vaporization to red and then used the arrow sign. Let me try it on this one, okay? So we're going to change we're going to put, can we do the arrow the other direction though? Yeah, I guess we could. All right. Yeah, we can. Yeah, so let's do that. So let's start with a blue arrow. So let's change the color here, my text color to blue. And then see if this works for me. Shift. Yeah, it does. All right, so I'm going to make this condensation. I like this. This really helps me, Revy. Makes it a lot easier. Condensation, blue arrow, make it bigger, 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 bigger. Can I make the arrow bigger by itself? Let me see. Yeah, I can do that. So I got blue arrow condensation. I mean, it's cooling down. I like that. It's a lot easier. Bold. Let's do that. Yeah, let's do bold. Let's do bold here. Where are you? Bold, bold, bold. There we go. Bold. Oh yeah, much better. Much better. Okay. Just gonna make it so it doesn't run into this one. Oh nope, I gotta keep it big. Condensation. All right. Let's go back to this one. So we're running out of time, ladies and gentlemen. So you see what I've done. So you've got the notes. The notes are in they're called Week 3 Phases of Matter BB, Mr. Barnes. So you can copy these down and then submit this as your bonus assignment. All right. So we've got melting, freezing and melting, sublimation and deposition. Okay. Sublimation and deposition. Okay, so we're on our way to getting the bonus assignment done. We got a couple minutes left. Anybody having any difficulty with this, let me know in the chat. And we got Revy kind of helped us out. It's much easier to do that than to do the drawing the arrow. But if you want to draw the arrow, you can do that. All right, just say goodbye to me when you leave. All right.